Hello guys, welcome to the StartPro tutorials. Today we will be discussing about this continuous beam subjected to different loads in StartPro. So let us begin StartPro. Select new project, select plane, give some name, meter and kilonewtons. Next we add beam, finish. Select to front view. Now you need to edit this grid. Since our continuous beam is 6 spans and 4 meter each, so we will be changing the spacing to 4 meters and the coordinates to 6 and the upper side 1 meter. Okay, so you can see 24 meters. Now we need 6 spans, so select 6 spans, 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, 20 to 24. Select escape, switch off the grid. Now you need to define the sizes. Rectangle, which is 0.45 by 0.3, add, close. Select the size, property, and select the beam assign to selected beam assign, yes. Now we need to assign the supports. Here you can see is a fixed support and all other are pinned supports. So we need to create two types of supports, create fixed support and create pinned support. So select fixed support and select the node, assign to selected node, assign, yes. Select the pinned support and select all other nodes, assign to the nodes, assign, yes. Now coming to loads and definition, load case details, add, primary, load case 1, add, close. Select load case 1, add. First is nodal load, which is minus 20 kilonewtons at second node and at fourth node. So create a nodal load minus 20, add. Next is a uniformly distributed load, which is minus 45 kilonewton per meter and minus 35 kilonewton per meter. This is to the entire beam and this is to the half of the beam. So initially minus 45, which doesn't require the distances, and coming to minus 35, the d1 distance is the distance from beginning, from the start of the beam to the start of the load. As you can see, this distance is 1 meter, so d1 will be 1 and d3 will be 3 meters, 1 3 meters, global y direction, add. Next is concentrated force, so select the force and magnitude is minus 30, select minus 30 and give d1 as 1, add, 3, add. Now coming to the linearly varying load is minus 50 kilonewtons per meter, so select W3 minus 50, y direction, add. Similarly you need to select triangular load, so select W1 0 and W2 minus 33, add. Now trapezoidal load, which is minus 20 to minus 40, so minus 20 to minus 40, add. And the remainder is the moment, concentrated moment, which is minus 30 kilonewton meter at a distance of 2 meters. Concentrated moment minus 30 kilonewton meter at a distance of 2 meters. this will be acting in global Z direction because movement acts in the direction perpendicular to the beam. Add, close. Now we need to assign all these loads. So select the nodal load which is at second and fourth node. You can get numbers by pressing shift plus N. So using node cursor, select the second node and fourth node, assign to selected node, assign, yes. Scale the loads. Now uniformly distributed load in the first beam, using beam cursor, select the beam, assign to selected beam, assign, yes. Scale the load. Now select the uniformly distributed load for the second beam, select the beam, assign to selected beam, assign, yes. And select the concentrated force in global y direction which is minus 30, select the beam, assign to selected beam, assign, yes. Similarly the second one. Now linearly varying for this beam, third beam, and now trapezoidal to the last beam and concentrated movement to the fifth beam. We can get beam numbers by selecting shift plus B. So we are unable to view the movement because the scale is very small. So in order to change the scale, go to labels, scales, increase the value of point moment. Apply. Okay. So you can see the movement. You can make it more smaller by going to scale and increasing the value. Apply. Okay. See. Now this is the continuous beam and we need to analyze it. So analyze and print, add, close, analyze in menu bar, run analysis, save. After analyzing is done, press done, go to post processing model. Okay, you can view the deflection, also can obtain the values from result, view value, beam results, maximum resultant, annotate, close. You can switch off the deflection, go to bending moment, obtain the values, shear force, obtain the values, go to modeling mode, general, loads and definitions. In order to view the values of loads, select right click, go to labels, select this load values box, apply. You can view the values, or else you can press shift plus V so as to obtain the values. So post processing is done in this way. This is the end of the tutorial. Thank you.